Okay, hi. So today I am going to talk about lovastatin, which is also called Mevacor, and just how it works to reduce cholesterol by acting on the cholesterol synthesis pathway. And I'll walk through its mechanism and activation, as well as its clinical effects. So, what is lovastatin? Lovastatin is a cholesterol lowering drug, and it's in the class called the statins. And it was originally discovered in the fungus Aspergillus terris, and it is primarily used to lower to treat hypercholesterolemia, which is just high cholesterol, and to reduce its cardiovascular risk. It is sold by the brand name Mevacor, and there's also others as well. And so in here I also included the structure of the lovastatin as well. Okay. Cool. So the cholesterol biosynthesis pathway is how you're able to understand how this works. So you first start off, or to understand how we need to just dive into it a little bit, because in the liver, cholesterol is made through the mevalonate pathway. So you're going to start with two molecules of acetyl-CoA, which I included here in an image, and then from there it condenses to form HMG-CoA, which is 3-hydroxy 3-methylglutarol-CoA, and that's step 2, which is over here on the right. And then from there, HMG-CoA reductase converts HMG-CoA into mevalonate, and when it's converted into mevalonate, it is considered like the rate limiting step in the cholesterol synthesis. Mevalonate is converted then after that into many different steps, and then ultimately into cholesterol. Okay, so after that, the mechanism of action is that lovastatin works by competitively inhibiting HMG-CoA reductase because its structure is very similar naturally, so it binds very tightly to the active site of the enzyme and prevents the enzyme from converting HMG-CoA to mevalonate, which would then reduce the cholesterol synthesis anyways. But a little fact is that statins have a higher affinity than HMG-CoA, so it's actually going to be a little bit easier for it to bind. Okay, the activation of lovastatin. An important point is that this is a prodrug, and it is administered in the form as its existing form, which is the closed ring lactone. And then in the body, specifically like the liver, it is hydrolyzed, which is opened into beta-hydroxy acid, which is the active inhibitor. And so then from there, the activation is performed by enzymes, and then following that, the consequences in the liver is that the lowering of the intracellular pool of cholesterol in the liver cells triggers this cascade effect, and the sterile regulatory element binding proteins, or the SREBPs, are activated, and then they move to the nucleus and increase transcription of LDL receptor genes, and they're placed more and more on the liver cell surfaces, and then more LDL receptors is more LDL is taken up into the bloodstream, and that lowers blood plasma LDL. And LDL is the bad cholesterol. So then pleiotropic effects is that lovastatin and other statins, they also do other things as well. So they reduce inflammation by lowering markers, they stabilize atherosclerotic plaques, and improve endothelial function. So that way the blood flow improves. And they also reduce the formation of lipid intermediates, which can also affect cell signaling. And then also in the pharmacokinetics, some key pharmacokinetics is that they are highly bound proteins, highly protein bound in the blood, and the oral bioavailability is around 90, it was about 30%. And then its excretion is mostly through the feces. So then, because of its pharmacokinetics, it is recommended to be taken with food to increase absorption. And then risks and side effects. Like other statins, there's obviously risks involved. Muscle-related myopathy and rarely rhabdomyolysis, but also in the liver, it can elevate liver enzymes. There's also a rebound effect, meaning when you stop taking lovastatin, the liver may react by increasing HMG-CoA reductase production, and also the drug interactions must be monitored carefully due to the pleiotropic effects as well. If they're not monitored, they could have ultimately really negative effects if they are obviously negatively interacting with each other too. So to conclude, the lovastatin is converted into its active form in the liver and competitively inhibits HMG-CoA reductase, blocking the rate-limiting step of cholesterol biosynthesis and ultimately lowering LDL in the blood. Thank you.